Alright, so I chose to do my presentation on Google Translate's update to using neural machine translation. So in September 2016, Google updated their Translate app to use neural machine translation instead of phrase-based translation. And this allowed them to reduce their translation errors by an average of 60% compared to the phrase-based model. A few years back, they started using recurrent neural networks to map sentences between the languages, but this didn't initially have any performance increase. But with the advent of the cheaper processor units, the TPUs, and some ingenuity, they were able to develop systems that increase the efficiency. So, how does machine translation work? I'll start with the word-based models. These started at IBM under some research done there in the 1980s. So the word-based models split a sentence into words, and they'll use a parallel corpus of translated text. So this will kind of be like what Professor Gemmel was talking about with the UN documents, and it'll calculate all of the counts of translations of different words. So, for example, on the left, you have the table where beautiful translates to hermosa, bella, or guapa, at a count of 80%, 16%, and 4%. So it'll use that highest probability translation to figure out what word to map it to. But there is an issue where the sequence of words aren't translated as a single unit, so this creates what's called a word salad, where the words are correct in translation, but the order is confusing or disorganized. So phrase-based models address this word salad and contextual information issue. And you'll see that here, instead of having individual words, this is just one segment. The sun was, beautiful is another, and last Tuesday is another segment. And you can see based on the last slide, last Tuesday doesn't really translate directly. You get some weird translation there. And here you get the actual translation for last Tuesday. So you make up for that weird contextual information issue. So once they came out with the neural machine translation update, this does entire sentences instead of the phrases or words. So their model uses what's called a long short-term memory recurrent neural net, and it has 8 encoder and decoder layers using what's called an attention connection from the decoder to the encoder. And just using the recurrent neural net wouldn't have alone sped up their translation. They had to use the TPUs to allow low precision arithmetic to speed up the translation, and also they improved rare word translation by splitting the words into a set of subwords. So from a high level, the encoder, for example, encodes Chinese words as a list of vectors, with each vector representing the meaning of words read so far. So you kind of have the memory there. And once the entire sentence is read, the decoder generates the English sentence one word at a time, and it pays attention to a weighted distribution over the encoded translated vectors relevant to generate the English word. So here's a visualization they had on their website. It'll take each character, split it up into the encoder vector, and the decoder uses that attention layer to kind of figure out the context to translate into the efficient translation. So moving forward, machine translation is not solved. That's a pretty big one, and this model can still make large errors that humans wouldn't. It can drop words or mistranslate proper names or rare terms. So the main thing to focus on is the difference between the models and human level translation. And here's just a little diagram of where we're currently at given Google's neural machine translation model. So you kind of see this increase from phrase-based to their neural net. And then there's still a little bit we have to make up for to completely get to a human level of translation. So there's still some to do on the research side to make up for that lack of error and mistranslation. So hopefully this gave you a better idea of what the update was, and thanks for listening.